Hello, what's up? So today I'm gonna go through review graph, okay, standard graph and further graph. Okay. So I don't really have a plan for every videos I make lah. So everything is very on the go. So let's begin. Okay. So firstly, right, you must understand like what are the different kind of graph that you need to know lah. Okay, so you need to come up with a way to be able to so-called capture all of them. Okay, so there's only a few ways that um, math can a few form that expression can take up. Okay, sorry, it's very early in the morning and yeah, I got no preparation, so everything is on the go lah. Okay, so imagine an expression, right? It can be okay x to the power of one. After that, you will naturally think of okay x to the power two, x to the power three, x to the power four. Okay, after that, because like all these are positive integer, then you could have thought that or maybe there's a x to the power negative one, x to the power negative two. Okay, and after that etc. lah. Okay. And after that, you think that maybe there's a now that there's all these integer, right? Then maybe there will be a uh, fractions. Okay. Then all these are polynomial of x lah. Okay. So x is at the base. So maybe x will be here in other cases, okay, which is your exponential x. Okay, because you have exponential x, you will have convex. Okay, after that is all your functions of the graph. Function means an operation to a certain values. Okay, so we have your sine x, cosine x, tangent x. Okay, and after that you have your modulus x. Okay, yeah. So math can only like the this kind of a few ways. It can only have a few ways to be presented. Okay, so you need to come up with your own way to be able to like capture all of the different forms, and after that reproduce each and every one of them. Okay, so firstly, this video, right, I will go through the most basic graph. Okay, then after that a build up from it, like a related graph of the same family, then how do you draw, etc. Okay, so let's start with all the basic graph lah. Okay, this x to the power 1, 2, 3, 4, right, all of them, right, okay, you are just gonna sub in values like what we always do in secondary school, right, the xy thing. Okay, then you sub in all the values. Okay, you don't have to draw this box, but then I'm just saying is something we learned before, but then we kind of lost touch of how to connect everything. Okay, so anyway, you just for x equals to y equals to x. Okay, when x equals to 1, 2, 3, etc. Okay, then okay, then you can draw the line. Okay, after that is your x squared. Okay, yes, when it's 0 is 0, when it's 1 is 1, when it's negative 1 is negative 1, when it's negative 2 is, sorry, it's negative 1 is 1, when it's 2 is 4, when it's negative 2 is 4. Okay, so it's gonna look like that. Okay, so this is y equals to x squared, and after that your y equals to x cubed. Okay, 1 to the power 1, 2 to, sorry, 1 to the power 3, 2 to the power 3, 3 to the power of 3, 27. Okay, 27, 8, 1. Okay, and likewise here, negative 1, negative 8, -8, -27. Okay, so it's like this. Okay, so all the basic graph, right, you can actually make use of your substitution and your knowledge with numerical values. When I say that, it's like, oh, you kind of know 2 square and 3 square, right? They're gonna be a bigger change, bigger difference compared to 1 square and 2 square. Those kind of things, like your your sensitivity to the magnitude numbers, right? Okay, make use of that, and then make use of your substitution in the um, in the expression in the equation, right? Then you will be able to form all these very basic shape. Okay, so if you were to do it for x to the power of 4, right? Okay, it's gonna be the same thing. Okay, 1 to the power of 4, 2 to the power of 4, 3 to the power of 4. Okay, that's why the shape was still like this. Okay. So after that is your power of -1. Power of -1, again, right? I say it just now, right? But I don't know whether you take notice. You have to be very sensitive to the numerical characteristic of all these operations. Okay, for example, 1 square, 2 square, 3 square, how does it change? Then now 1 over 0.001x and 1 over 1 million, how does it changes? Okay, so 1 divided by 0.0001, right, is gonna give you 10,000, 100,000, 1 million. Okay, so it's a very big y value. Okay, a very small x value and a very big y value is gonna produce this thing. Okay, that's why I'm talking about y equals to 1 over x. Okay, so that's why you need to be very good with all this kind of understanding how to the numerical values of different situations. Okay, which I believe is somewhat related to what you have learned in primary school. Yeah, then we kind of that's the thing about how we learn. We like to keep throwing away the fundamental as much as possible, right? And then retain like the uh, cornery, like the result, the resultant uh, of at this stage. Okay, then we forgot all our basic, and we then cannot interrelate each of them. Actually, the best way to do it, right, is to focus on your basic, okay, and then build everything ground up. Okay, so that's the purpose of Ground Up Academy lah. I want you guys to learn differently and learn with greater clarity with relying on your basics. Okay, so over here, right? Yeah, so a very small x gonna give you a very big y. Okay, I don't know how many zero are, so yeah, please don't flame me for it. Okay, yeah, and after that, 1 divided by this one, right? A very big x, right? Is gonna give you a very small y. Okay, a very big x, okay, and a small y. So it's not here. Okay, as a result, right, your graph will look like this. You go closer and closer and closer. Okay, likewise, right, if I add the negative here, right, this will be a negative. That's why a very small magnitude negative number, right, negative x, right, is gonna give me a very big negative. Okay, so it's gonna be here. If I add a negative here, then this one will be like this. Okay, so that's why you can derive the shape on your own. There's no need to memorize. Try to understand, like, you have, it cannot be just take what I say for granted. You need to, I don't know, incorporate in your learning. Okay, like everything that I say is to try to change the way you learn. Okay, so really, I don't know what apply what I learned, apply what apply what I share, okay, and then learn a different way. Okay, you need to take the initiative to really experience the easier way. Okay, okay, so that's it for 1 over x. Okay, so looking at 1 over x squared, right, it's not very different now. Okay, thinking about the 0.01 and 10,000, etc. Okay, so it's gonna be like this, but then on the other side, right, it's gonna give us positive values. Okay, that's why the graph will look like this. Okay, just go and sub in a value and then you will see what I mean. Okay, so after don't know how long I'm recording, right? I never memorize any graph. Okay, so I don't want you to go and memorize, and I hate it when students try to memorize and they memorize wrongly and they got penalized for that. Okay, I feel that that shouldn't be the way of learning, and that shouldn't be a way of evaluating intelligence of a student. Okay, it can be very fun, so let's make learning very fun. Okay, so pardon for the messiness, okay, but then all this we have done already, okay, and then all this we have done, okay, then after that square root x, okay, square root 1 is equals to 1, okay, square root 8 is equals to 2, okay, the difference is 1, but the difference here is 7, okay, so it kind of tells you that the slope, right, need to the gradient need to decrease over when x increases. Okay, so this is y equals to square root x, okay, which is this thing now. Okay, so again, it's nothing different. Just up when it is 0 is 0, when it's 1 is 1. Okay, when x is 1, y is 1. Okay, when x is 8, y is 2. Okay, so like that, done. Okay, now think of negative values of x. Okay, so you can now square root negative. So this is the graph. Okay, do note that this one doesn't curve backwards. Okay, this one will just keep increasing, but it will increase very slowly, but it will still increase. That means to say there is no asymptote. Okay, whereas here there is a asymptote because this thing can never reach 0. It will become very, 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 very close to 0. Okay, this one there's no limit. Okay, and you square root 9999999. Okay, then 999999999. Okay, it will just keep increasing. It doesn't tend to a certain number. Okay, so that's all for the then exponential and ln. Okay, the sine, cosine, tangent, those again is either you use calculator to find the key points, right? Or you just go and memorize. Okay, I personally for me, I just do it enough to know what's the shape of. Okay, so next up, let's talk about exponential and ln. Exponential and ln is something that students have difficulty memorizing it. Okay, so the way that's why when I study, right, how I eventually come up with all these way of learning and perspective, right, is when I was in secondary school, my friend tell me that if I study this much for O level, right, I gonna study this much for A levels. Okay, so from day one, right, I try to make sure that don't happen. I make sure that the week before A level, right, I can study and memorize as little as possible. Okay, that's why that's why I come up with all these way of not memorizing but still be able to produce the correct notation, correct formula, correct graph, etc. Okay, so again, think of the numerical value lah. Okay, so here is y equals to e to the power x. Okay, if I'm not wrong, value of this is 2.7 something. So you can just treat it like 2 or 3. Okay, and then square that. Okay, here. Okay, so let's say it's a 3. Okay, so it's 1, 9, 27, and then I don't know how much. 3 times 27, 81. Okay, yeah, 1, 9, 27, 81, right? Between 27 and 81 is 60, right? Between 27 and 9 is 10 plus, okay, so it's 8, 10 plus 60, okay? So it's a 50, okay? So the increment is very big, okay? The increment very big, so it should look like this, okay? Something like that. Okay, then now let's look at the how about on. Okay, so when this one is x is 0, right? Okay, e to the power of 0, okay, it's gonna give you y equals to 1. Okay, that's why I draw wrongly. You should cut around here. Okay, and after that, let's look at the power, the y when the power is negative. Okay, so e to 2.7 to a power of -1, and then 2.7 to a power of -999. Okay, so how do I know what value to sub inside, right? When is it -1, etc., right? It's really based on the x value. So your distinction between your x value and your y value need to be very clear. There's a lot of times that student was doing this, then after that they just mix up the x and y values, then the graph looks very weird. Okay, so yeah, take note of that. Okay, it will get practice. It will get better when you keep on practicing the this kind of way, substituting numerical value. Then you will be very sensitive to, okay, when you are using when you are at x, when you are at y. Okay, the categorization will get better if you keep practicing. Okay, so over here, right, this one, right, is 1 over 2.7 to the power 999. Okay, so that means, right, it's gonna divide by something very big. Okay, so it should tend towards 0. Okay, so as a result, right, it will go to nearer to 0 and nearer to 0 and nearer to 0. Okay, so this one can know. Okay, so that's your graph for exponential. Okay, next up is your y equals to non-x. Okay, so do note that y equals to non-x and ex, right? They are inverse of each other, ma. Okay, so if they are inverse of each other, right? If I draw the y equals to x, okay, then the graph for non-x should look like this. Okay, so there is non-x, and the asymptote is here, okay, just over here the asymptote is here. Okay, so that's all for the graph. Okay, now why I never try to calculate this non-x, right, is because it's an operation when something is like sign something, it's very difficult to tell you what's what's the result. Okay, ln x is also an operation. Okay, it's very difficult to estimate the numerical value of it. Okay, whereas this one we can roughly guess and see the magnitude. But then when it's a function, right, it's very difficult. Okay. Yeah. So that's all for your most standard graph. Actually, what did I just do? I just sub in value and understand the characteristic of the numerical values. Okay. the numerical characteristic of the different operations, the different forms. Okay, so you need to be good with that, and you are able to do that because that is kind of in your subconscious. Okay, you did it before. It's just way too long ago. Okay, try to find it back and then be familiar with it. That's all. Okay, now let's take a look at the further graph. Okay, so further graph, right, is derived from um, all the most basic graph. Okay, that's why the chapter that I teach first, right, is transformation. Okay, after you know transformation, right, you're gonna know how to you're gonna be better at the further graph lah. Okay, so um, yeah, so in terms of y equals to x, right? Okay, yeah, so you must also understand the different characteristic of a graph lah. Okay, uh, um, so for example, 2x plus 7, right? Okay, then you must know that this one means what? Okay, this one means what? Okay, so if you look at 2x first, right, it actually means increase in gradient. So in my mind, there will be an image of if this one is like that, okay, this one is going to be like that. Okay, so y increased by 2 when x increased by 1. Okay, so the graph should roughly look like this. Okay, then after that you shift our 7 up. Okay, so I'm gonna go like this. Okay, so yeah, that's it for your linear graph. Okay, next we look at y equals to x squared. Okay, so yeah, that's why x squared. Okay, so it look like this. After that, you need to start to think of a lot of different formula, which um, cross over with your knowledge with projected equation. Okay, so for example, x plus 5 squared. Okay, this one very simple because we learned in the previous video about transformation, right? This is replacing x with x equals to x plus 5. Sorry, replacing x with x plus 5. Okay, so it's a shifting to the left side by 5 units. Okay, so it's like this, then like that. Okay, then this thing will keep on going up. Okay, then will keep on going up. How I know? Because I know that when you sub in the x value, etc. lah. Okay, then you square it back. You can still sub in, can still sub in, can still sub in. Okay, so is there any other way that is similar to any other expression that is similar to this thing? Okay, so one could have guessed that, or maybe x squared plus 4x, okay, plus uh, 6x, okay, plus 5. Okay, so they are still similar and they are the same family lah. But then how do you get how do you express the key features, right, in this graph? Okay, you need to rely on your knowledge in your projected equation lah. Okay, so what have you learned? Okay, you learn how to do a factorization. Okay, you also learn how to do a complete square. Okay, so how I do this so far is I got my own technique, which hopefully in other videos, I probably in one of those practice videos that I will share with you. Okay, this minus one. Okay, this video is for you to focus on um, the graph. Okay, the graph and the photograph. Okay, so yeah, based on these features, right, you know that your graph is gonna intersect at x equals to -1 and x equals to -5. Okay, and they are turning point, right, is gonna be -3, -4. Okay, so how to draw this kind of graph? Okay, usually I don't student like to draw very directly to the connecting the points. No, okay, this part spread out as much as possible. Okay, after that, okay, so be as gentle as possible. Okay, after that, become more steeper and steeper and steeper. Okay, so that's why math is very, I don't know, it's like a skills that you need to practice. Okay, yeah, you need to practice it. It's, I feel that math is like playing chess. Yeah, that you need to train enough for you to, for your mind to work a certain way. Okay, so that's it for quadratic, and then now we will go to cubic. Okay, this is gonna be a long video. Okay, so cubic. Okay, so just now we have seen that when it's cubic equation, right? Okay, the graph is gonna look like this. I know, just sub in values and you will see. Okay, so over here, right? What are the similar form? Okay, a similar form can be like just now I say, x plus 5. Okay, so it's nothing different from just now what we do. We are just replacing the x with x equals to 5. X with x plus 5. Okay, so it's just a shift. Okay, but then it can be something that is like this. I don't know. It's just some random stuff I created. That's why I keep emphasizing that I didn't prepare for the lesson. A lot of things is on the go. And I think that that should be, you should pick that out as like it's really possible, right, to kind of master math, right, when you master the fundamental. So imagine like you don't have to always flip back at your lecture notes. Okay, you literally can build it ground up. Yeah, and then whenever you need to do certain question, some practice, you don't need to go and take your lecture notes, then figure it out for 30 minutes, then do. No, straight away build it up. Okay, so yeah, I don't know what is this factorization gonna be and whether it can be factorized or not. Okay, so all these are hypothetical. Okay, so for example, this one is x plus 2, it becomes x plus 2, x plus 3, and x plus 4. Okay, so in this scenario, right, we have three roots, right? The roots are -2, -3, and -4. Okay, so the graph will somehow cut, and cut. Okay, so you see, this graph is like that, okay. So it kind of makes sense that our graph need to be like that and like that. Okay, so for it to be a root, right? You need to intersect, okay. So the way that intersect, right, it's like this, okay, can yeah. Else, there's no other way. The only way to make them all intersect and make these to point to this direction and this direction is this way, okay. Now let's say, right, your graph is something like this. Okay, then yeah, I don't want you to relate, this one is just this one times negative, and that's why you do it. See this example, right, as a standalone. Okay, so I got these three roots already, right? Okay, you need to think of uh, how you're gonna intersect them. Okay, because this one x cube is like that, okay, so negative x cube, right, is gonna look like this. Okay, we should flip it around. Okay, so if this is a negative, the coefficient of x cube is negative, okay, your graph gonna somehow look like this. Okay, after that, the only way to intersect all of them is like this, like this, like this. Okay, so now we are not done yet. Let's think of other examples of how else can the what are the other scenarios. Okay, so the other scenarios that you could thought of, right, is maybe the graph can be like that, like that. Okay, so yeah, in this scenario, then how would the expression look like that? Okay, so if in this one, right, it says got one root, okay, but got turning point. Okay, so it should look something like this: x plus 1, sorry, x minus 1. Okay, after that, this thing, right, is because no real roots, okay, no real roots means this one cannot be factorized, as in cannot, this projected equation here, right, won't have a roots, okay, that means is b squared minus 4ac, right, is more than 0. Okay, so that this thing cannot be equal to 0 lah. Okay, so b squared minus 4ac is more than 0, so I give it a very big a and a very big and very small b. Yeah, okay, so the discriminant is less than 0 lah. Okay, this kind of scenario, then it will look like this. Okay, done. Okay, so we have seen that, right, that the uh, the projected graph will look like this or like this. Okay, the cubic graph will look like this. or like this, okay, or like this, or like this. So based on guesswork, okay, we will guess that x to the power of 4, right, okay, should look something like this. See, compare this one and this one. Okay, initially it's like that, right? After that, you add this thing, right? So x4, right, should be you add this thing, yeah. Okay, so it will look like this, okay, or it will look like this, okay, or it will look like, sorry, the curve is smoother, yeah, okay, like that, like that, like that, okay, then after that, like that, like that, like that, like that. Okay, then or it's just a normal x4 and negative x4. Okay, so then you will know how does x to the power 5, etc. will look like. Okay, so now let's look at 1 over x. Okay. Okay, so just now we have said that the standard graph for 1 over x is this. Okay, so this one is y, this one is x. So y equals to 1 over x. The thing about this is I always think, okay, what other expression, right, can can fit into the family of this. Okay, so for example, right, okay, we can maybe do this. Okay, okay, we can maybe do this. Yeah, okay. As a result, this is one of the family. Okay, but if you look at this, right, and you are good with your algebra manipulation now, okay, you'll understand that, okay, another form that is fit this, right, is equivalent, which is like this. Okay, so all these, right, is going to fall in the same family of these because it's just the most basic standard graph. Then you do some transformation. Okay, now after that, you start thinking of, hey, this one is power x to the power 0, then x to the power 1. Then maybe x to the power 2, okay, well, it's also a same family. Okay, okay, so all these 1, 2, 3, I don't need to cover that. It's just transformation. Okay, go and do yourself. I would like to. Okay, I will cover this. Okay, so this one, okay, the graph shift by 1 unit to the left, then shift out by 1 unit. Okay, so your new asymptote is going to be this. Okay, from 0 shift to left by 1 unit. Then your asymptote, right, is being shifted upwards. Okay, so this is another asymptote. So it's gonna look like this. Okay, be very mindful with how you draw your curve. I'm doing it very lacklusterly because yeah, because I'm I'm screwed up lah. Okay, so yeah, make sure that this thing don't curve back. Okay, just go closer and closer and it never touch. Okay, likewise, the other part also never touch. Okay, so I would like go closer and closer. Okay, done. Okay, go closer and closer. Okay, done. Okay, then connect. Okay, so this one also go closer and closer and connect. Okay, All these x-intercept and y-intercept, right? You can figure it out later lah. When x equals 0, y equals 0. Okay, this kind of stuff. Okay, so now we have seen that, right? Okay, whatever that is written here, and whatever that is written here, right, is the asymptote. Okay, as such, right, if we simplify this one, right, to y equals to x bracket x. Okay, to this form, right? Okay, it's gonna look very similar to this. Okay, it have a something plus a reciprocal, something plus a reciprocal. Okay, and just now we say that these are the asymptote. So in this sense, right, this thing and this thing should be the asymptote. Okay, so drawing the try to relate it to the graphical context. Okay, I have a asymptote x equals to y equals to x minus 1. Okay, so it's going to look like this. And then I have asymptote here. Okay, so I only have a asymptote. Okay, so now is how to draw the graph lah. Okay, so asymptote says that your value will tend closer and closer and closer to it, but won't touch it. Okay, so based on this, right, we will know that our graph, right, will be something like this or something like this. Okay, so some may ask, how come cannot be like that? How come cannot be like this? Okay, this one also tends closer into the asymptote. Okay, so my answer to you, right, is that because you need to understand in what scenario, right? Okay, in the most basic form, right, will it look like this? Okay, that is when your y equals to 1 over negative x. Okay, so because of your this sign here is a positive, right? Okay, that's why, right, your graph is gonna look like this. Okay, because over here the uh, the sign here is positive lah. Okay, so your graph look like this. Okay, when it's negative, it look like this. Okay, so for the situation to for this kind of graph, right, your equation will be y equals to x minus 1 minus 3 over x plus 1. Okay, over here is y equals to x minus 1 plus 3 over x plus 1. And so the sign of this thing, right, okay, is going to determine which quadrant is your graph going to take. Okay, so that's it for the reciprocal graph. Okay, 1 over x squared, I think that one you won't be tested too much on the oblique asymptote, etc. So that one I will skip. Yeah, we very rarely talk about it. Okay, usually you are just tested with 1 over x squared. Okay, so next up is our exponential and ln. Oh, we are finishing. Okay, wait. Okay, so food for thought. Okay, let's say now is x cubed plus like that, okay, over x plus 1. Okay, I know how to long divide this, okay, but I'm just going to give you a rough form of what this will look like. Okay, so this will be a x squared, then after that, here like that, some constant plus x plus 1. Okay, then plus some constant x plus some constant. Okay, maybe they are 0, I don't know. Okay, but you do long division, this is what you're gonna get. Okay, so you won't be asked to plot this kind of graph. Okay, because um, the asymptote will look very weird. Okay, for example, this one is, I don't know, let's just say like this. Okay, so it will go closer to the asymptote and closer to the asymptote and closer to the asymptote and closer to the asymptote. Okay, but then like you don't have to show that this one is the asymptote. Okay, yeah, because it doesn't. Yeah, it's yeah. You can just show this the asymptote to be this thing, because this thing will tends to infinity and isn't bound by a x. And then this thing also tends to infinity. Okay, so this kind of, so there isn't really a point of talking about it, because who wanna talk about asymptote like this? It doesn't. It makes things very messy. Okay. Okay, done. So next up, exponential, and we are finishing. Yeah. Okay, exponential graph, like that, like that, like that. Actually, it's very simple. E to the power x. Okay. After that, just do your transformation. Okay. It can be 1 plus e to the power x. Okay. E to the power x minus 1, etc. Okay. Do your transformation. Okay. Then after that, your ln x, also same old thing. Do your transformation. Like this, like this. Okay. 1 plus ln x. Okay, which not gonna do a lot of difference to the uh, how the graph look like. Okay, then shifting on the x around, thus changing your asymptote. Can do one example here. So it shifted to the right by 1. Okay, now your new asymptote is this. Okay, so that is all for your standard graph. Okay, yeah. There is still things like y equals to fx, y equals to 1 over fx, etc. So yeah, but if you learn what I say just now, right, y equals to f mod x, stuff like that. They give you this without telling you the expression. They just show you some random graph. Okay, then you're supposed to um, find all these derived form, as in the manipulated form. So yeah, but yeah, all these things, if you really really truly understand what I mean by all the numerical values, etc., right, and sticking to your x and y, being clear when is it x, when is it being y, right, this thing shouldn't be difficult for you, okay, and the transformation that we do last lesson. Okay, so can't help you further. You need to put in the work to master these kind of skills, and then things will be very easy. Yeah. Okay, so that's all for today, and I will see you in the next video. Peace.